they have great experience, ton of experience in pen testing, ethical hacking, and they're gonna go through this talk about the Webview security, as you've already seen from the slides, and especially they will talk about the journey behind the Webview CVE that they discovered and reported to Android. Guys, the floor is yours.
Thank you, David. First of all, I would like to thank you all for joining this session. We'll be talking about securing web views and the story behind CVE 2021-21136. I'll be walking you through this presentation with my friend and co-speaker, Imdadullah Mohammed. So let me start this with quickly introducing ourselves. My name is Shiv Sahni. I work as a senior associate with JP Morgan. I'm one of the contributors in OWASP, MSTG, and also the author of the gray matter of securing Android applications. Over to you, Imdad.
Hi, thank you, Shiv. Hi, guys. My name is Imdadullah Mohammed. Currently, I'm working for Grab as a security engineer, and I'm leading the application security initiatives for various engineering teams here at Grab. Over to you, Shiv.
So before we go ahead, a quick disclaimer. Any opinions expressed over here solely belongs to us and are nowhere related to our current or past employees. So this would be the agenda for today's session. We'll be starting this with discussing CVEs and web views. We'll talk about how exactly web views work. Once we have established the foundations, we'll talk about the timeline on CVE 2021, wherein we'll discuss about the overall journey that we went through and the communication we had with Google security team. Next, we'll talk about the in-depth analysis that we performed in order to claim the CVE. Last but not the least, we'll talk about common web-related security issues in the way wherein we could prevent those issues in order to make our apps secure and robust. So let me start this with introducing CVEs and WebView. CVE is an acronym used for Common Vulnerability Exposure. It's actually a unique identifier that is associated with a vulnerability in a publicly available software package. I hope, and I believe most of you guys would be aware of the term CVE, though WebView might be an alien term for a few of the folks in the audience. That is why we'll just establish the foundations first, and then we'll jump to the analysis on the Chromium CVE. So CVE 2021-21136 is a unique identifier that is associated with a vulnerability in Android web views. So during our security research, we observed that a lot of mobile applications were actually leaking users' auth tokens to third parties. So when we dig deeper into it, we found out that this was happening due to a flaw in Android WebView implementation. We'll talk about this in detail in the upcoming slides. So this was just to introduce and talk about on a high level what the CVE was all about. So now let's talk about web views. So WebView is one of the mobile app components that allows mobile developers to load web content directly into their mobile apps. So if you see an image over here, I have provided the URL, and then the corresponding web content for that particular URL is loaded in the mobile app itself. So you could consider it to be a dedicated web browser of the mobile app. Since they support the concept of code reuse, as a mobile developer doesn't need to rewrite the code from scratch and can just use the same the same code that is already available. It supports the concept of code reuse, and that is why it's extensively used in the current era of mobile application development. So now we know what a web view is. Let's see how exactly it works. So as I mentioned, we just need to provide the URL that is to be loaded in the web view, and then the corresponding web content is loaded as a part of our mobile app. So if you see a code snippet over here, we have a load URL API. So basically, this API endpoint takes a URL, and the corresponding web content is being loaded at the mobile side. So what happens at the backend is, when we are using this load URL API, which is an Android API, and we have provided a URL, so the front end would make a network request to www.google.com, and the corresponding web content would be received by the front end back from the Google servers. And once it reaches at the front end, the corresponding web content is rendered in the mobile app in the WebView component. So this was the simple way, or I would say a normal load whenever we are using Webviews. What happens when we want to load a content that is protected through authentication? For example, let's say we want to load users' profile page. Again, backend won't release users' profile data until and unless we are passing the auth data, since it is a restricted content, protected content. In such cases, we would need to pass the auth data in order to let backend release the protected resource. So if you see over here, we have an overloaded version of load URL API, wherein apart from providing the URL that is to be loaded, we also pass a map. So basically, headers is a map which is having key value pairs, where key is the HTTP header name, and the value is the corresponding HTTP header value. And what happens is, when this API is used, the front end would make a HTTP call to the backend, and this request, the HTTP request, would have all these headers attached to the request. So now if you see, since this is a protected request, what I have done is I've passed the authorization header, which would have my authentication token. And now backend would entertain this request and would release the protected resource. Once it reaches at the front end, it would be rendered. So if I just sum it up, we have two flavors of load URL API. One is a normal load, wherein we just provide the URL and the corresponding web content is loaded. The other one is an overloaded version of load URL, wherein we can leverage the same to load an authenticated content or a protected content. So now we know what a WebView is and how exactly it works. Now let's talk about Deeplinks. So Deeplink is kind of a URI which helps developers to improve the user experience. So by URI, I mean Uniform Resource Identifier. Let's understand this with help of an example. Have you ever wondered while you're browsing web content in the mobile browser and you click on a link and it opens a specific content in the mobile app that is installed on your device? This happens because of deep links. If you see an image over here, while Googling, I searched for a particular product, and then I click on a link and it opens that particular product in the mobile app that is installed on my device. So all this happens because of deep links. So deep link is nothing but a URI, a Uniform Resource Identifier, which opens a specific content in the mobile apps and improves the user experience significantly. So now that we know what WebView is and how exactly WebViews work, and a brief on deep links, now let's talk about the journey on CVE 2021, 201136. So all these things that we discussed would help you understand the analysis and the journey in a better way. My co-speaker, Imdad, would be taking over from here. Thank you, Imdad. Over to you.
Hi, Shiv. Thank you for briefing the audience with the basics of WebView and how Deeplink works. So from here onwards, I'll be talking about a journey towards our CVE 2021 to 1136. So first, I would like to talk about an basic example of an OAuth. So in a standard OAuth use case, where we have this specific slide, here we are talking about a standard OAuth use case in the context of mobile application. So in this context, we have a mobile application, we have an identity service, and we have a third-party service. So let's assume our mobile application integrates with a lot of third-party service with the help of OAuth. So as soon as you click on the tile, on the third-party tile on the mobile application, the first call will go to the identity service with the client ID as well as redirect URL. In this specific call, the user's authorization token will also be sent in the header since it is an authenticated call. So now what the identity service will do is verify the auth token, as well as it will match the client ID as well as the redirect URL and generate a ID token for the user, and it will give it as a 302 response to the mobile application. Now what the mobile application will do, it will redirect to third-party URL along with the ID token to the third-party service. After this, a couple of request happens where the user gives a consent to share its data with the third party. And finally, the user in the mobile application can access the third party services. So this is a basic OAuth use case example. Now let's move on to understand what was the bug at a very high level. So if you see at this step where the user has now got the ID token and he is being redirected to the third-party services with the redirect URL and the ID token. So in this specific request where we are having an additional header, the user's authorization token was also being forwarded to the third-party service, which means that the user session token, which belongs to this provider, is being shared with the third party. So this was an observation at a very high level. During couple of use cases, reviewing couple of use cases, and after replicating this issue, what we have concluded in our initial observation was that if you're an Android mobile developer, then you would understand that when you're implementing a web view and you're trying to use load URL, and you'll of course use the pass the URL inside the load URL which you want to load inside the web view. And in a case where we saw an example where we are talking about authenticated load, we would pass additional HTTP header, which will be the authorization header, and in the authorization header you will pass the session token. So when you're doing an authenticated loading in such a case, then it sends the additional header to any other request trigger in the process of loading the URL, which is such as redirect. So as we have seen in the previous example, even if it is a redirect, the origin, even if it's a redirect and the origin is different, the user's authorization token was being exposed to the third party. So this was our initial observation. Now in this slide, let's talk about let's talk about the timeline, how we started doing our research and how it ended up in an CVE. So in August 2019, we while doing our regular research, we observed this behavior, and we suspected that there could be an issue in the Chromium. So in December 2019, we started to doing a deep down investigation about this issue. We developed our own Android application. We had our backend application written in Python, and we wanted to replicate this issue, and we submitted an entire analysis to Google. In January 2020, we got a response from Google that this is an intended behavior and they wanted more analysis, to do some more analysis. And finally in Feb, Google accepted, and they said they require more time to fix because of compatibility issue. And in November finally in November, the official fix was released in Chromium 88. So this was a timeline of how we got our CVE. Now let's get into in-depth analysis of the actual issue. So here towards the right, what we are seeing is a demo application which is simply loading a WebView, which is simply loading a URL scratchpatch.org inside a WebView. Towards the left, the code snippet here, what we are able to see is that an Android WebView component, as you can see, we are doing a load URL, WebView load URL, loading the URL over here, as well as we are setting the additional HTTP header as the authorization header. And then once the URL is loaded, the headers will be sent across. So if you want to have a look at this issue, you can always take the code snippet from this link given over here. So this was our front-end application. Let's look at a backend. So backend is a very simple code snippet where we are just trying to do a 302 redirect. So irrespective of any request received in this web server, it will do a redirect to scratchpatch.org. So after when you actually run this demo application and try to intercept the traffic, this was the initial observation that, as you can see, the authorization header, which we have set in the initial request while we were loading the Webview URL, is being actually forwarded to scratchpatch.org. So now that we have seen a couple of screenshots of how exactly is happened, we have recorded a demo wherein we are trying to replicate the specific issue, having our own Android front end as well as the Python backend. Let me try to play that for you. So towards the right, what you can see is basically our Android code snippet, which is running on Android application, which is running on the Android emulator, and this is a HTTP proxy, which everyone knows that this is burpsuit, basically HTTP proxy. So let's play the demo. As you can see, as I clicked on this button, a request has been initiated towards my backend Python Flask server, and I'm loading the authorization header over here. And once I forwarded it, I got a response 302, and it is trying to redirect me to scratchpatch.org. Once I forward this request back to the client, which is the mobile application, again here, so scratchpatch.org is getting loaded, and if you see over here, the secret header, which is the actual user's authorization token, is also being forwarded to scratchpatch.org. So this was the exact behavior that we have observed in our research, that user's authorization token, which was being forwarded to the third party. So now that we have gone through the entire analysis, we know the exact issue. Let's have a look what was the actual fix that was rolled out and the rollout plan. So this was pretty much interesting to understand how exactly Google works when it comes to fixing a particular bug. So if you want to have a look at the code snippet, you can visit this link over here, which is given over here. So the fix was very simple. They had removed any extra header from the request if the request is being redirected to a different origin. So if there is an origin mismatch between the request and the response, then any extra header will be dropped because it could be sensitive. And then they wanted to record a metric on when we add header and what was done to them, which means that after the redirect, whether any header is being added in the process or what was done to that specific header. And the last but not the least, they had a test case verifying that the extra headers are clear up. So once this fix is in place, they wanted to make sure that there is no extra header being added anywhere in the process. So this was the rollout and official fix by Google. So now that we have spoken about the CVE, we have spoken about Deeplink, Webview, and we have focused more upon the exact CVE. Now she will take on from here, and he will talk about most common Webview issues that occurs. Over to you, Shiv.
Thank you, Imdad, for the detailed analysis. Now let's move to the second part of the presentation, wherein we'll be talking about the common web-related security issues and the way wherein we could prevent those issues and make our apps secure and robust. So over the time, what we have observed is these are the four most common web-related security issues. The first one is lack of URL validation, followed by insufficient URL validation. In both the cases, what happens is we are loading a URL, the web view, with no validation in place, the first one. And in the second one, we have a validation in place, but the validation is not sufficient and can be bypassed. So the first two are related to the amalgamation of web view and a trigger which helps load a particular URL in the web view. That trigger could be Deeplink or could be an intent. We'll talk about it in the next slide. The third one is unintended leakage of sensitive data to third parties. So this is very similar to the Chromium CVE that we talked about, wherein all those cases wherein unintentionally we are sharing users, auth data, PII, or some business sensitive data to a third party, all those categories of issues would fall under this issue family. Last but not the least one is insufficient Webview isolation. it captures the scenarios wherein we are leveraging or using our own web views to load in untrusted content. By untrusted content, I mean a partner content or a third-party content. We'll talk about all these issues in detail in the upcoming slides. Let's talk about the first two issues. So as I mentioned, it happens when we are loading a URL in the web view and there is no validation at all or a very minimal validation which could be bypassed. So let's understand the use case first. So there could be two UI components. By UI component, I mean an activity in the case of Android and a view controller in the case of iOS. So there are two UI elements. First UI element calls the second UI element and passes a URL while calling the second element. And the second element is actually having a WebView component, and it loads the URL that is passed by first component in the WebView component of the second component. So when we are calling the second component, there are two ways or multiple ways, I would say, wherein we could trigger this. The first one is a deep link. So we could use a deep link. If you recall, we talked about deep links, a way wherein we could improve user experience by just clicking on a specific link and it opens a specific content on the mobile app. So for this particular trigger, for calling the second component, we could leverage deep link, or we could have vanilla intents. Again, intents are just messages that two components uses to interact with each other. So it could be an intent or it could be a deep link. In both the cases, what happens is we are triggering this particular UI element, which is having a WebView component. And while we are triggering, we are also passing a URL, and the second component loads that particular URL. Now, in this particular use case, if while triggering the second component and while loading the URL, if we have no validation in place, it would fall under the first category. If we have a validation in place before loading the URL, it would fall under the second category. Let's understand this with help of some code snippets. So the first one wherein we have no validation at all. If you see, we have this Deeplink, Webview demo app, and this Deeplink is actually having a URL. So what happens is whenever this Deeplink is triggered, it would open this URL in the WebView. So if you see the code snippet over here, we have extracted this URL out of a Deeplink, and we are directly using load URL API to load this URL which we have passed out of a Deeplink. So if you see, we are not doing any kind of validation. So that is what a problem is. So we are not doing any validation, and we are directly opening a URL which is coming as a part of a Deeplink in our own WebView components. We'll talk about the impact in the next slide. Now let's understand the second problem. In this particular case, we have a same kind of a Deeplink Webview demo app which has a URL. While we are passing the Deeplink, we are extracting the URL out of it. If you see now, we are comparing this with a specific domain. So we are following the standard practice of whitelisting based validations, wherein we have a domain which is shivsahni.com, and I'm comparing this with the domain that I have got while parsing the URL from Deeplink. And I'm comparing whether the domain, the host matches in both the cases. So either the host should be shivsahni.com or it should be a subdomain of shivsahni.com. And once this validation passes, only then we are loading a URL. This looks the right way of doing things, right? Wherein we have a whitelisting based approach. We have a whitelist, which is shivsahni.com, and we are comparing against that whitelist. But the problem is the use of GetHost API. So there was a vulnerability identified in the implementation of GetHost method, which allows adversary to bypass the validation. So now let's understand this and magnify it a bit. So if you see, we have a crafted URL here. It is having two domains, attacker.com and legitimate.com. So what happens is when this kind of a crafted URL, which has backslash and @ symbol, separating two domains, is passed to GetHost method, it behaves differently. So it takes legitimate.com, it takes second domain out of this crafted URL, while when the same domain is being passed, so the same URL is being passed to load URL API, it takes the first URL. So that is how we could bypass the validation. So for validation, we have this legitimate.com. However, when we are loading a URL, it would load attacker.com. This was a very amazing finding, and Buggy Pro has written a very amazing report on this. So there is a hyperlink. Once we'll be releasing this deck, you can go through this. So the problem is, if I conclude, the problem is the implementation of GetHost method, as it behaves differently whenever we are passing a crafted URL to a GetHost GetHost API. So the fix is we should not use GetHost for validation. Instead, we should use GetAuthority. We'll talk about the secure way of doing things in the next section. But for now, I would recommend whenever we are doing a validation, we should not use GetHost, and we should always do a validation. So the first one, we were not doing any kind of validation and loading the URL directly. The second one, we were having validation, but that validation was of no use because it could be bypassed. This issue was fixed. The issue with GetHost method was fixed in API level 28. However, 27 and below are still vulnerable based on my analysis. So we should always refrain from using GetHost if we are supporting Android API levels 28 and below, 27 and below. So now we know what the issue is. Let's talk about impact. So again, if you see, we are able to load a malicious URL in Webview. Now it totally depends on the privileges of the underlying Webview, which is under attack. So the impact could be as simple as just loading the HTML content and phishing the users, or it could be as severe as executing remote code on the mobile device, or exfiltrating users' auth tokens. So it totally depends upon the privileges of the underlying Webview, which is under attack. The higher the privileges of the underlying Webview is, the more would be the impact, and vice versa. So if I talk about a few examples, let's say in the scenario wherein we have Webviews which are configured to have JavaScript bridges, that would allow JavaScript, which is not now under our control because our Webview is compromised. So this JavaScript could actually call the native methods, which could be Kotlin or it could be Java. So JavaScript code could call Java and Kotlin methods if this Webview is privileged enough to have interfaces, JS bridges in place. So just to conclude, the total impact of the issue would depend upon the privileges of the underlying Webview, and the higher the privileges are, the more would be the impact. Now let's move to the third issue, which is unintended data leakage. So as I mentioned, it's very similar to the Chromium issue we talked about. So there are multiple instances that we have observed wherein unintentionally developers leaks users or business sensitive data to third parties. Let's understand this with help of some examples. So if you see over here, this is a very common one, wherein we have seen multiple times users auth tokens or ID tokens are being sent as a part of referrer headers to Google Tag Manager. And Google Tag Manager is just one example. So it could be any third-party domain. So if you see the referrer header, we are passing users auth token to a third party. So we should always make sure that whenever we are having a third-party integration, all the network requests are logged and verified for some potential leakages. In this one, if you see, we are doing an authenticated load to a third-party domain. If you recall, we talked about a normal load in the Webview and authenticated load. In the authenticated load, we pass auth data as a part of headers, additional headers, and front-end passes those headers to the domain. And they are not meant to be shared to resource servers. They are only meant to be shared to identity servers, which would validate those auth or data. So if you see, we are leveraging the same Webview component, which is doing an authenticated load to load a third-party domain. In this particular case, we are sending JWT to a third-party domain. The next one is sharing auth data or any other sensitive data as a part of query string. So query string so whenever you are passing anything as a part of query string, it would be logged at backend. And by this, I mean anyone having access to logs and everyone having access to logs would be able to retrieve that sensitive information, be it QA engineers, be it mobile developers, be it security engineers. They would have access to sensitive data, including auth tokens. So whenever we have to pass some sensitive data to backend, we should never use query string and a get verb for making the HTTP call. We should always send it as a part of body in the post request. So last one is lack of Webview isolation. So as I mentioned, whenever we are leveraging our own Webviews to load a partner content or a third-party content, all such issues would fall under this category. Again, let's understand this with help of a use case. So let's say we have an application which is integrated with a lot of third parties. So what what happens is a user could use third-party services through our application, and these applications are being accessed by user through a web view. So our application is having a lot of web view components corresponding to the third parties that are integrated to our app. So whenever a user clicks on a particular link, it opens a web view and it opens a partner content, and then user could actually avail services that are provided by third party. And this is something which is very common in the current era of like super apps. So what happens in this scenario wherein, let's say we have this kind of a implementation wherein the partner content is loaded as a part of web views. So in this particular case, if we are using our own web views to load the partner content, we are actually opening a door for potential leakage. So what could go wrong is if there is a breach of trust or the third party or a partner itself is compromised, the expected legitimate content would be replaced with some malicious JavaScript. And again, we are allowing, since we are using our own web views, the malicious JavaScript would run as a part of our own web views. And again, now it depends upon the privileges of our own component. So the attacks, in fact, could be as simple as just phishing the users by just loading some malicious HTML, or it could be as severe as exfiltrating users' auth tokens or doing a remote code execution on the mobile device. So whenever we have this kind of implementation in place, we should never load partner content in our own web views. We'll talk about the ways wherein we could prevent these issues, wherein we could leverage Chrome custom tabs in the case of Android and Safari view controllers in the case of iOS. And that will be taking care of those recommendations. So for now, we have discussed the most common web-related security issues that we have observed over time. In the next section, we'll be talking about learnings and recommendations, the way wherein we could prevent those issues and secure our mobile apps. Imdad will be taking it over from here. Over to you, Imdad.
Thank you, Shiv. Hi, guys. Let's now understand what are the learnings and the recommendations that we have so far from the entire research and from the entire analysis. So the first and foremost, like in Android, whenever we have a content provider or whenever we have a Deeplink, let's assume that we have a Deeplink. In the Deeplink, and if we are trying to pass a URL in the Deeplink, so the first thing what we recommend is to do a secure URL validation. So to prevent cases where we have seen there are vulnerable functions such as GetHost, which will actually bypass the check, we must always use GetAuthority. So here, this is a sample Android code snippet where the function validate URL takes in an URL object over here, and after that it checks whether it checks the authority as well as the scheme. So once this passes, the function will return either a true or a pass. The second set of example is in iOS. This code snippet provided over here is a Swift code in which we are using the URL component.scheme as well as URL component.post. So here I'm trying to do the same thing and extract the scheme as well as the post from the URL and validating it, returning either false or true. So this is how what we recommend to do a secure URL validation whenever you're trying to accept a URL from the user via the Deeplink or any other way. So as Shiv already spoke about Webview Isolation, so this feature comes into a picture where you're wanting a user to access the third-party service without any interaction with your native app. So for example, you don't want to have a native bridge, or you don't want to do an auth load, or you don't want to share any data. You just want the WebView to be isolated. So in that case, in Android, we have custom Chrome tab, and in iOS, we have Safari view controller. So this is what we recommend, like when you want to browse a third-party services. So why? Because it actually doesn't run as a process of that application. Instead, it runs as a process of Safari as well as Chrome process, which actually minimize the risk of running a malicious JavaScript accessing non-exported services and other component of the mobile application. And apart from that, as it acts as an embedded browser into your application, it also gives a seamless user experience. So let's assume, let's have a couple of checklists when you're trying to, secure Android Deeplink, or let's say when you're trying to harden Android Deeplink. So the first and foremost point is disable implicit access to content providers. So the set allow content access property will by default disable, by setting this property, it will disable access to your content provider. So in case you have some sensitive information stored in your content provider, it can be accessible via the web view, but with this specific property, you can disable it. And the second point comes to the local storage. So we have a lot of information in the app's local storage, and this can also be accessed through the web view if we leave the default setting on. So you can disable it using set allow file access. The third point is with the help of clear cache, you can flush the web view cache whenever the web component is no longer required. Last but not the least, it's very important in most of the cases where you don't have a JavaScript bridge between your web view and as well as your application. So in that case, simply with the help of this property set JavaScript enable, simply disable the JavaScript bridge, so that the attacker is not able to access any sensitive information with the help of Deeplink or with the help of any non-exported activity or content provider. So now that we have spoken about Android, let's talk a little bit about how you can achieve this in iOS. So in iOS, people used to use UI WebView, which is actually now depreciated. So if you have an application in UI WebView, it will no longer be accepted in the App Store, as well as update to the existing application is also not accepted. Why? Because it had a lot of settings which was by default enabled, and it was which in turn is an open attack surface to steal sensitive information to the attacker. For example, the JavaScript, as we seen in the previous example, we were able to disable it, but here if you want, you cannot disable it, and other sensitive settings are also enabled by default. The successor of the successor of UI WebView comes the WK WebView, wherein we have different properties with which you can harden your WebView. For example, using the JavaScript enable property, you can actually disable the JavaScript bridge, and we have hash only secure content property to make sure that the content loaded in the web view comes from an encrypted connection. And apart from that, similar to Android, we have allowing read access to URL. Whenever you are whenever you're having this setting enabled and you have a static page you wanted to load in your web view, make sure that you do not give access to the entire directory, rather specifically give access to that specific file which you want to load it in the web view. So apart from that, we have allow file access from file URL and allow universal access from file URL, which are security sensitive settings which can be disabled by default if it is not consumed by the feature. So let's move on to the key takeaways from the entire presentation. First and foremost, always follow the least privileges while WebView. For example, disabling the security settings that we have spoken in the previous slide. Also disabling JavaScript if it is not required. Only allow those properties that is consumed by the feature. Second one, always use custom Chrome tabs in Safari View Controller whenever you're trying to load a third-party content so that the malicious JavaScript cannot access cannot have an interaction with your native web application. Third one, if your as we have spoken about the secure URL validation. So if our Deeplink is trying to load the URL, ensure that URL is validated in a secure way, and always while validating the URL, have an explicit match with the authority and protocol with a whitelisted set of URLs. Last but not the least, always when you're trying to do a third-party integration, make sure you have a test case in place. Like in case of Google, they had a test case to make sure that no sensitive data is being exposed, and also have a check on logs that whether we are unintentionally sharing any sensitive data to third party. So we want to we are coming to the end of the presentation, and we want to thank a couple of people like Mona Vinodan. Mona Vinodan was involved from the end-to-end analysis, and he was a great motivation in doing the entire research. And we also want to thank Changmuk for helping us during the analysis. And these are the couple of references that we took in our research and while preparing the entire presentation. I think that's all from our side. We are open for questions. So if the attendees have any questions, they can ask us or leave the question in the Slack channel. Thank you.
I believe we don't have sufficient time left for questions. You can always reach out to us on LinkedIn or Twitter if in case you have some questions.
Yep.
Thank you, everyone.
Thank you, guys.
Yes, please. Thanks to you, folks. We have still a couple of minutes before our break. I actually have some questions, so if we see if that keeps some time for others to come up with some questions. It's more about again statistics. I would say it seems through this presentation that security is hard, right, in general. So it seems like you have to do your due diligence while implementing web views. So you have to again parse and perform a lot of security related controls and measures. Do you have any statistics or that basically tell us roughly how many implementation of web views are actually lacking some security measures? I'm talking about, for example, I don't know, 20% of your application that you analyze following some issue with security on WebView. I don't know if you have done this type of research.
So I'll take it. Basically, we don't have any statistics. So that is why we cannot come on a specific number. But based on our analysis, what we have observed is most of the times, I would say 9 out of 10 times what we have observed is web views are not configured properly. So what happens is web views by default have certain privileges. So these default privileges are not even required sometimes. So that is why we are unintentionally expanding the attack surface. So this is something which is very common. So whenever we are configuring web views, we should follow the principle of least privilege. So 9 out of 10 times what we have observed is web views are overly permissive. So I can just tell you something based on my analysis, but we don't have statistics behind this. But yeah, this is something which is very common.
Yeah, I recall that, WebView, it's, there are some vulnerabilities and CVEs around, WebViews in the past, right? So it's a very sensitive component, as you have shown, right? So powerful, but still, requires the due diligence, right? That we have to. So yeah, again, thank you very much, folks. And again, if attendees, you have any question, we have the public channel. You can, write there your questions or reach out directly to Shiv and Imdad. Thank you very much, gentlemen, for your time.